This is the overall hardware setup for the project titled Cost Reduction for an EV Charging Station Integrated with Battery Energy Storage and PV Generation. These are the basic hardware blocks involved. The first block is the boost converter block. The second block is the inverter block. This block is the bidirectional converter with inverter block. This is the controller block. This is isolation block. This is the gate driver block. And this is the three-phase resistive load, which can be considered as grid. The input to this circuit is a 12 volt 10 watt solar panel. Now the blocks in detail. The first block is the boost converter block. The 12 volt DC would be from the solar panel would act as input to this boost converter. The 12 volt would be boosted across the boost converter and will be able to see a boosted output across this resistive load. The second block is the inverter block, wherein we have 6 switches which are MOSFET IRF 840. The next block is the bidirectional converter with inverter block, wherein we have 8 switches which are also MOSFET IRF 840. The isolation for these MOSFETs is provided by the gate driver circuit that is present here and the optocoupler that is present here. We have used the gate driver circuits present in this block to isolate the MOSFETs, and this is the optocoupler used for isolation. We have used TLP250 for that, and this is the microcontroller block, wherein we have used PIC16F877A microcontroller. The operating voltage of microcontroller is 5 volts. Initially 12 volts is given as input to the circuit. Of that 12 volts, only 5 is used for its operation. That is done by the regulator IC7805. This is a crystal oscillator used for giving clock pulses. Now the operation. Initially will connect the solar panel of 12 volts as input. This input from solar panel would go to the boost converter, wherein it will be boosted. The boosted output would go to the inverter block. From the inverter block, it will go to the three-phase resistive load, which will act as a grid also. From this grid, it will go to the bidirectional converter with inverter block. At this place, we can also charge a battery. While the input is from the solar, using the bidirectional converter with inverter block, which will get its input from the three-phase resistive load or grid, we can charge a battery. And in the second phase, when the solar panel input is removed, when there is no input from the solar panel, the battery which got charged in the first phase will act as input to this circuit. At that time, from the battery, it will come to the bidirectional converter to inverter with inverter to the grid. And in this grid, we can also run a load. We can see a lamp glowing when connected to this grid. Now we'll switch on the circuit and see how it operates. We have switched on the circuit. We can see the LED glowing. This shows that the circuit is working. We have given a light source to the 12 volt solar panel. We have connected the probes of the multimeter at the input point, and we can see 12 volts being displayed. This is the input that comes from the solar panel. And this input of 12 volts is boosted across this boost converter and we are getting around 30 volts which can be displayed in the multimeter. This is the boosted output of the boost converter. This boosted output would come to the inverter block. From the inverter block it will go to the three-phase resistive load which can be considered as grid, and the probes of the DSO are connected across the resistive loads, and we can see an inverter output being displayed. This also shows around 30 volts. Each block is 10, so 30 is being displayed. 30 volts is coming across the inverter block, and we can now see the battery charging. We have connected the multimeter probes across the battery wire, and we can see that the battery is getting charged of around 23 volts, 22 to 23 volts. This goes into the battery. This charging can be used for charging the battery of electric vehicles. So at this point this will act as EV charging station. Now in the second phase we'll remove the solar panel and we'll get an input from the battery that gets charged during this phase. Now in the second phase we have removed the solar panel input. We have disconnected the solar panel input, and the battery which got charged during the first phase will act as the input. The input from the battery will go to the bidirectional converter with inverter block. From there it will go to the grid, which is the three-phase resistive load, and across this resistive load we can see an inverter output displayed in the DSO. At this point we can also run a load. Now we'll see now we have connected the resistive load to a lamp load, and we can see the lamp glowing. Now it is disconnected. Now we are connecting the load, and you can see the lamp glowing. This is when there is no input from the solar panel, and the battery that got charged acts as input and to the bidirectional converter with inverter, and from there it goes to the grid, and we can run a lamp, run a load across the grid. This is cost reduction for an EV charging station integrated with battery energy storage and PV generation.